First off, let me preface this with saying that I hate doing intros for videos. This stuff drives me nuts because I always mess it up. So here's what we're going to do today. I've done videos about 9340 relays, which is a double pole, single throw type of setup. I've also done circuit board videos. This is a Goodman fan board. It's got the relay for the fan motor, it's got some other low voltage connections, and it's got a low voltage fuse. I've done a comparison of those. Here lately, there's been talk about more commercialized controls. So what I'm going to do today is I'm going to put a commercial type control in a residential air handler. This air handler's been wired and rewired, and I actually took it and resurrected it before, and we got rid of it, and now it's come back again because it serves a good purpose. So today what I'm going to look at, and this is where your homework lies if you want to follow it, is there's more than one type of control. For our traditional controls, classic controls that you might see as a young apprentice, a young helper in the residential market, and even in some commercial, you're going to get into on-off controls. Switches, normally open, normally closed. If they're together on a relay, you might have a common terminal. And that's essentially what this rib relay is. It's nothing more than a traditional control. It has a nice LED light on it, and I'm going to show you, what it looks like in just a second. But there are many different types of controllers out here. A lot of us will probably only deal with the traditional. But for those of you that venture on out of that market and you get into building automation and stuff like that, you have to know sequence of operation, you have to know how to think about the building, and I'm not trying to go there yet, but what I'm going to do is show you a different setup, a different type of control that's easily applied to what we already know. So stay tuned. I'm going to try to keep this short and sweet. The last one was like 45 minutes, so I didn't even post that one. So let me show you what this relay looks like and some details on it, and then we're going to wire from scratch an air handler and show you those circuits. Alright, I'm going to try to do this without casting shadows or whatnot on here, but this is what you get when you open the box that this rib comes in. Like I said, it's a relay in a box. Right here on the data plate it shows it says relay in a box. That's their little trademark, their little namesake. So it's nothing more than that. So on top of it, and I'll throw up the spec sheet real quick, but you've got your coil voltages listed. And what we can do here, we have a common connection, and we have 120 volts AC to the coil, or you can use 10 to 30 volts AC or DC on here, and that falls in line with our residential style 24 volt control system. So I'm going to use it in our Aries air handler that we've done before. So coil voltage on this side, and if you look on the other side, there's going to be your switches. You've got a normally closed, a common, and a normally open, and this looks exactly like a Goodman fan board. It looks exactly like a 9340 relay. Like I said, it's too simple. What we'll do is we'll look at the wire colors, the color with the stripe on it. So we've got a white with a yellow stripe, and we've got a white with a blue stripe, and we've got a white with a black. All the stripe stuff is your coil voltage related wiring. And then the solid colors, blue, yellow, and orange, that's going to be your switching colors or wires that you're going to use. So I like it because you can mount it into the side of the unit with screws. So they give you 2 screws, probably about 2.5, 3 inches long, probably 2.5. But I can drill a pilot hole and mount them inside a unit, or I can mount them on a panel or through one of the knockouts on the side. I've seen it in the building we're in and on jobs that I've been to out in the field. This is mounted to like a junction box. So you just knock out one of the 1/2-inch knockouts, and you've got more than enough wire to go. What I'm going to do here is I'm going to cap the 120 volts coil voltage connection wire that I have here. I'm going to just cap it and leave it there because you never know if you might want to use this relay somewhere else. And I'm going to use a ring on the end of all the wires that we are going to use today, And you'll see that we're going to put a terminal block in just to try to keep it neat so we can do some voltage checks. Alright, so we know we're putting in a rib relay. Here's our standard air handler. Let me get all this junk out the way. I've got some wires hanging over the side because we're going to rewire the heat strips in here from the terminal block. I also have, here's my rib relay, and I've already put terminal rings on the end of them just to make it easier, because right here is a terminal block that I've set up for my low voltage connections on the left hand side, my hot and common, and I also have my 3 terminals off of a standard relay, in this case this rib relay, but I've got a common, a normally open, and a normally closed, which is the exact terminals that this Goodman fan board has on it. So as I've said before, if you think about what you're looking at, this stuff is too easy. So let me throw this out of the way. So terminal block for high voltage over here. We've got sequencers. We have a double stack limit switch right here that is for our heater kit. We've got our transformer in the corner. I've mounted a thermostat right here on the side. And here is our fuse holder. So I've also put a ring on the side of it. If you open it up, you'll see a 5 amp fuse right here. It's ready to go. So we're going to take it from scratch. And I'm going to mount this rib relay inside the air handler. I'm going to start out by wiring the low voltage. Now I've got all my terminals for my rib relay right here, and I have capped off the 120 volt connection that we're not going to use. So I'll wrap it up and curl it under here, but everything else is going to be you know, with a ring on it, so we can easily put it under these screws for this terminal block, and it'll make it easier for voltage checks or you know, future use. So first things first, I'm going to wire my transformer low voltage. Now I've got the high voltage over here, and we'll do the high voltage at one time, but for low voltage we're going to have it all under here. Okay. So we've got our 24 hot connection here, and it's going to basically go right through out of the transformer straight into our fuse holder down to the thermostat or the low voltage connections that we're going to do to the thermostat wire. Alright, so here are 4 low voltage connections on the common side. I've got the original common from the transformer. I'm going to have my common to the sequencer that we're going to wire in just a second. I've got my common from the thermostat connection, the thermostat itself, and I've also got my common from the relay. So there's 4 of them. They're all coming back and ultimately going to go to the transformer. So now what we're going to do is drop down here, we're going to drop down here and we're going to start and wire the thermostat connections. Now this is standard setup here. I have we're not using the Y circuit because I've just taken this air handler. It's only going to be used with electric heat, so we're going to wrap the Y circuit around from the thermostat itself. Okay, so I've got my red from your thermostat wire going to the fuse holder, so that's the hot connection. I've got my black wire here at the thermostat that is tied to the common connection. What we're going to do now is, remember there's a white with a blue stripe. That connection goes to the rib relay, and it is now our indoor fan circuit or indoor fan relay circuit. So I'm going to do that low voltage connection there, and when the thermostat sends power out on G, then it's going to energize the coil of that rib relay, and then we've already tied in our white yellow, which is the common for the rib relay coil. So that connection is previously done. All right. With the white, what I have, I'm gonna, as I said, we're gonna start from scratch. So I'm gonna run a white wire down through this little bushing area. So white to white. Pretty much everybody probably knows that's watching this video, but now if you think about it, where's the other end of this white go? No matter what safeties it goes through, limits or whatnot, this has to go ultimately to your heat relay or your heat sequencer, heat contactor, heat whatever you use to turn it on. Okay, so if it was a gas furnace, it's ultimately going to the gas valve. But we've got electric strips here, so this white, once it leaves this wire nut, it's going to go and we're going to wire it to our sequencer. Alright, so our white right here is going to go, we can try to make this as neat as possible. So we'll just loop it under here, and this bottom connection, usually it's the closest to that plate that you have. I would say the bottom, but this thing's mounted on its side, so somebody somewhere is gonna, gonna get me. But so the W from the thermostat is ultimately going to go to that heat sequencer. These are high voltage limits right here, so we're going to save them for just a minute. So W to the heat relay, heat sequencer, and then the other side over here is going to be common back to our transformer. We started on the power source on R. If we were calling for heat and that sequencer is going to be used, then we're going to ultimately go R to W inside the thermostat. The W circuit's going to hit here with the hot connection, 24 volt coil as we'll call it, and then back on common. So that completes that. So the rib relay is done, the transformer connections are done, the heat sequencer is done. Now we're going to move into the high voltage. So now that we have our low voltage done, what we're going to look at is the high voltage. Here's our terminal block. We have two heaters in here, one on the left and one on the right. So this is a heater and this is a heater. I'm only going to wire one of them. The principle will be the same for the second one. I just don't have enough amp draw on this particular circuit that I'm going to plug into, or this particular outlet I'm going to plug into. So we've got to wire up the heat strip. We got to wire up the transformer because we have to have high voltage to get low voltage. We have to wire up for the fan motor because our blower has to run anytime the heat strips run. So when we're coming off the terminal block, they've already labeled these here, and it's going to be L1 and L2. To me, that doesn't matter. I remember that I have to start on one side and end on the other. You can start here on the one that's on the upper section as you're looking at it, and as long as you end on this one, everything should be fine. Or vice versa. I can start on the bottom and end on the top. No matter what your choice is, I should say, in a situation like this, because if you ever go to maybe a mobile home where everything's just burnt up, I've been to a couple of those, or maybe there's a electrical fire, I don't know, pick your poison. But if you ever have to wire a circuit from scratch, and this is the easiest way right here for me, there's nothing here. I get to choose everything. I think what gets a lot of guys, and I'm going to try to do this in another video, is reading the wiring diagrams and interpreting that. So when we have a situation like this where it's kind of bare bones and we get to call it what we want, it's too easy. But whatever circuit you run first dictates the rest of everything. A lot of times we are thrown into the situation where everything's already wired. We're finding out where the problem is, not necessarily like this. So what I'm going to do here is I'm going to call it just like they have it here, L1 and L2. So every circuit will start on this upper one where the white the white wire is, and end here on the bottom where this black wire is. So my transformer, right? Transformers and thermostats, they're two loads that are always on. They don't have a control switch to turn them on and off. They're on all the time as long as power's on. So what I'm going to do is, I know that my red and my black, I've already looked at the transformer. These are my high voltage connections here. So I'm going to run L1 into the transformer, and this is going to be my L2, this black one right here. And now that I call it that way, this is always L1 and this is always L2. So transformers out the way, we have the high voltage, that's going to give us the low voltage, all that's done. Now let's look at a heat strip. Okay, so I'm going to take here, I'm going to go L1, and I'm going to go into my sequencer. So power into our control switch. When we come out of that control switch, we're going to go through a safety. So that's a safety in series. And the way this one is, this top is a switch and then the bottom two are a switch. So we're going to use this top one. All right. So power goes into a control, and we're on our way to our heater, which is over here. power, control, our load. So now we have to return back to the other side of power. So we're going to take and change colors here. It's black. And we're going to go right there and return it back to the terminal block. And now that one heater is done. I've got the yellow wires over here to distinguish the second heater in case we were following it, but you can go back and dig up a video on that one. I've already done that. So our transformer's done, our high voltage on our sequencer, and the electric heater, like that whole circuit's done. Now we have to look at the rib relay and the fan. So as we're looking at this, what I've got off the rib relay is I've got these solid color wires. I've got a blue, an orange, and a yellow. And if you look, yellow is common, the blue is normally closed, so the orange is normally open. And I'm going to attach these to that terminal block, and instead of using wire nuts, like I said, it's going to be a little bit easier when we do voltage checks. Alright, so let's look at the rib relay and how we're going to wire up the fan through this. Alright, so we got normally closed, common, normally open. I've already terminated the rib relay side of things. What we're looking at now is connecting the fan motor to it. So what I'm going to do here is common. Alright, there's so many commons we use in especially residential heating and air. We have a common for relay and switch situations. We have a common for the 24-volt side of our transformer. We have a common on a PSC motor, one of the 3 terminals. We have a common on a capacitor. I mean, it's a bunch of different commons. You have to know when to apply it. This common right here is basically, no matter if we're using the normally closed or the normally open relay, we're getting power out of that terminal, right, out of that wire. So what I'm going to do here is I'm going to put my PSC motor, I'm going to put my speed on that common. Now I've got my red and blue, and this is black, okay? So whatever speed you're using, the way most manufacturers are probably going to, like I said, residential wise, if you see this setup, we're going to have a multi-speed PSC motor, but we're only going to use one speed for heat or cool. That's exactly what Goodman does with theirs. So that is going to go, and I can change right here. I can change the speeds if I need to adjust the CFM. So what do we do with normally closed and normally open? Well, normally open is going to be the easy one to address. What we're going to do is normally open only closes, right? We only close that connection to the common terminal when we have a call on the relay for fan or cool. So we have to have an energized coil on this relay in order to use that switch. So we're going to use that in fan mode. We're going to use that in cooling mode. And what I'm going to do here is I'm going to put straight L1 power. L1 comes from over here on the terminal block. I'm going to put straight L1 power on that connection into the normally open switch. When I get a call for cool or for fan, it'll come out of the common. Alright? A lot of guys get messed up on this normally closed connection. Where do we get it and what's it for? This is easy. Alright? The normally closed connection we're going to use in this setup as a redundant safety for heating mode. Now we've only got our electric heat up here. Like I said, treat this as a conventional setup. What we're going to do here on this normally closed is we're going to tie in our heat strip with the fan. I don't need a call on G for the fan to work in heat mode. I have this circuit right here, and it is a high voltage connection between the normally closed on the fan relay and the sequencer for the heat strip. Right here I've got L1 coming from the terminal block going into the sequencer. When the sequencer, on a call from W, right, that white circuit right there, when the sequencer is told to turn the heat on, that one wire goes through the switch, right? It brings power through the switch and it splits. One goes to the heat strip itself, and then we have this purple one. with the first heater that comes on, we need the fan to come on. So we're going to come out of this sequencer switch to turn on the heater, and we're going to turn on the fan, but we have to use the normally closed connection. There's a lot of thermostats out there that will automatically turn on the fan no matter what, but just in case, we have a normally closed switch on our fan relay that will do that. And honestly, that's pretty much it. I'm going to turn this on and make sure it works, which I'm pretty confident that it will, but we got to double check and make sure. Now, since we have our L1 going into the normally open, and we have basically L1 coming from the heat strip circuit off the sequencer, both of those are L1 going either circuit into the rib relay, and they're coming back on the common going to our fan speed. The one thing we have left to do is to terminate the other side of our PSC motor, and since either one of these, purple or the normally closed or the normally open, they're both L1, so this wire right here has to be L2, and we're going to terminate L2 over here on this bottom side of this terminal block. And with that being said, I mean, everything else is already wired, so a circuit at a time, and you can chip away and wire it back up. Hopefully it's easy to understand. I think it's fairly easy, but I've done it once or twice. So let's turn this on and make sure that it works, and then we will jump into some voltage checks. Alright, we're plugged in over here inside. Alright, we got 210 volts coming in, so we got good power. Let's run it through its paces. We'll do some checks and make sure that everything's going to work all right. Alright, the blower just cut on. I'm pulling 18 amps or so on the heater. Blower's going to pull 1.2. So our heat strips work. Like I said, we could have easily wired in a second heater over here. It would have been the same concept. L1 into the second switch on the sequencer, out of the second switch into the limit, over to the heater, and then back to L2. So same concept, it just repeats. Hey, I hope you learned something about wiring up this rib relay. You can use it many different places. This is just one of them. I think I'm going to put it in my air handler at home, to be honest with you, so just because I like the light. But we're going to take this unit again, and we're going to put in some different relays like this ice cube relay. Show you that. I've also got a current sensing device that we can do some different things with. So if you just take the time to try to get these things straight in your head, do your research, make sure you get the concept, make sure you understand the sequence, this stuff is fairly easy, and it won't be any problem to use. Alright, so we can do a couple things. I mean, with the power off, of course, our terminal block is over here, and you can see we're pulling about 208 volts. That power is going to go to the transformer. If I was going to check 24 volts out of the transformer, then I'm going to check over here to our low voltage side of this terminal strip. We got 27 volts going. If we wanted to check the voltage to the coil, I would need to go down to the low voltage that we wired, take that thermostat or that cap off, and I've got 27 volts on my rib relay coil, and you can see over here that that little LED, that red LED light is on. So what if the fan wasn't working? Well, you have to remember that just like on the 9340 relay, that all of these terminals for the switching side of that rib are just one side of power. So if I check here, if I check the L1, it's going to say 0. Or actually, oh yeah. Alright, so this is L1 and this is L2. So if I was following, I mean, I've only got the fan on, so if I was following, I would follow this going into the normally open. So I've got my L2 over here on this bottom terminal screw of the terminal block. So that's power going in. If the switch is closed, then it'll come out here on the common. So I know that my fan should be running, and of course it is. But look what happens when I check the other one. 0. Why? Because this leg, this normally closed leg over here, has no power on it right now. There's voltage there, but the way that we're reading it is we're on the same side of power, because we're backfeeding actually through this heat sequencer, and it's checking the L2 side. So L2 to L2, if I'm checking in this situation, is 0. No difference. Doesn't mean no power, means no difference. Alright, and the red light's still on. And there we go. So now I'm going to turn on the heat, make sure it works that way. So I've got this set up, as I said, for a one-stage heating, and the thermostat is programmed so that the fan is operated by the system, not operated off of the G necessarily in this case. So we're going to let that, if I check, oh, there it goes. So if I check my heater, I've got 17.6 amps. For my fan, I'm going to have, there's the yellow right there, I'm going to have 1.23. So as far as function, we wired it in right. And now what will happen is, if I go on my L2 terminal block and I check here, I've got 208, but only because it's already plugged into the terminal. Alright, look at what happens with the purple. I've got 208 as well, or 206, and of course my common's going to have 208, 206, something like that. So basically all three of these right now will read power, because they're all actually touching L1. The normally open has L1 coming from the terminal block right here on that wire, so I'm just on the opposite end of where the wire connects. The purple has L1 because my heat relay is sending power across the sequencer switch, and when this heater starts power here on this red wire, it also sends power down that purple one. So it's also an active L1, you could say. And then my common, being the way out of this rib relay, is my high voltage coming out. So my fan is on, and I've got power on that common too. So everything worked good. One low voltage check I'll show you real quick, because this was not meant to be a terribly hard video. Oh. If I can get it off. There we go. I don't know how many people pay attention, but right here to the left and right of that 5 amp fuse number is a bare piece of metal. If you were ever checking a fuse to see if power was passing across, now I know that as I read it here, power comes in on this side. So if I'm checking there, I can get my 24 volt, and it tells me. But I can check, leave the fuse in play, and check to see if power came out, and check it on that side of the fuse. So don't neglect those two little little indentations where they give you a bare piece of metal. So, but that's a rib relay. It's really nothing different than a 9340 if you buy the proper one.